You've put in the classroom time. You've done the lab work, not to mention all the extra hours. Now it's time for some real-world hands-on research. Join the next generation of science, technology, engineering, and math professionals at a Department of Energy National Laboratory. You can start with a sponsored internship, scholarship, or a research opportunity.
I'm excited about the next generation of STEM workers. I'm particularly excited about the programs in DOE. We need chemists, geologists, ecologists, biologists, mathematicians.
I'm really glad I have Dr. Looney as a mentor because he's really enthusiastic about the work that he's doing here. I've definitely gained interest in things that I hadn't thought about before, especially in nuclear chemistry. One of my projects is to design equations that basically describe how mercury transports through our existing mercury removal processes. Trying to merge these equations so that they can make sense. I'm coming up with first-order kinetic modules to basically describe the light as a function of depth in our photoreactor when we expose our samples to light. So it's pretty cool to actually conduct the experiments in the lab and then actually have on paper mathematically exactly what's happening while we're doing that in the lab. So that was pretty fascinating to me.
This is like the new I believe the DOE labs need a very diverse set of employees in terms of young people, different backgrounds, different ethnicities, different areas of the country. The more diversity you have in developing applications, the better your product's going to be.
I was not familiar with nuclear science until I came here, so they definitely taught me a lot about that and what kind of jobs it can bring.
With the gamma, you don't have to because plastic.
So I was working on foam synthesis for radioactive shielding for the decommission and deconstruction of nuclear facilities.
So she is developing, testing, as well as reporting all of the aspects of this project. So she's actually doing really well.
So interns can expect to have a project that lets them experience what it's really like to work in a national lab environment where they can get their hands on the actual research that's going to have an immediate benefit either to the lab or to the DOE complex. Navigation point 1, which is over there by those buoys. You've got to have a whole range of skill sets in order to actually do big science nowadays. We're going to need folks that are able to work well in teams, know their field of expertise, and also to be able to work with others to come up with a complete solution. All right, let's lower that thing in there.
I'm working on a project in tandem with SRNL to design a field measuring device that will measure cesium levels in bodies of water across the site.
Cool, all right.
Specifically, what I'm working on is building the controller of that boat. That means building all the circuitry, programming all the circuitry, making modifications to the hardware so it can connect and immediately be able to make it an autonomous boat drone.
On the sides. So this is a cross-organizational project and we're in the process of testing it.
Every day you learn, you're more than you were before. You've grown, you've changed, you've become something better. Especially once you get into research, like real research, you're going to be looking at something, some piece of data, some idea that's never been ever. And now you're looking at something totally unique. So when I take the ODs, I can't really be certain that the OD is correct.
Koji has been working on a project with BioTiger, which is a patented microbial consortia developed by Savannah River National Lab here.
It's basically bioremediation with the intent of scale up for industrial processes.
The BioTiger Consortium actually degrades unique compounds in terms of naphthenic acids, which are of an environmental concern.
I feel like a lot of the experience is very hands-on, and I've set up hundreds of samples at this point. Definitely learned how to work a lot of equipment I didn't know how to work before. I like the GC. I like running the GC. I like seeing the chemicals appear and disappear, and I like planning the experiments. That's the part I really enjoy.
And so this information is extremely important. Koji's actually been building on that, looking at the environment and the conditions, and it's been a real success.
I think the most important thing for the next generation of workers is being exposed to as many different opportunities as possible. All of the larger goals and missions of the site really require the collaboration of chemists, engineers, physicists. So having the willingness and flexibility to learn new things and work with folks in different fields is a very important skill to cultivate. That's the road to success.
We're helping develop an analytical method that is used to measure plutonium concentrations.
And so we have been doing a little bit of troubleshooting with the programming and testing of some of the pieces to just really perfect it and reduce error.
It's been challenging for sure. I'm really thankful that I had the opportunity to be surrounded by people that are the best in their field, and they're just sharing their knowledge. It's just been a mind-blowing experience.
I think being a mentor to the young scholars is one of the most rewarding experiences. You can see that they are so eager to learn and to become the next generation of STEM leaders.
To me, being a scientist or engineer is about innovation.
Uptake the solution and maybe still a drop, right? Negative.
I'm working on synthesizing and testing hybrid nanophoto-catalysts for environmental applications. The goal is to create an efficient and removable catalyst that destroys organic pollutants in wastewater streams using solar power. To have a mentor to guide you and give you the insight and give you that knowledge transfer of having so much experience in the field allows you to really develop and learn much more quickly than on your own.
The Department of Energy realizes a well-trained, technically skilled, and diverse workforce is needed to successfully complete its mission. Help enhance U.S. security and economic growth through transformative science, technology innovation, and market solutions to meet the nation's energy, security, and environmental challenges.
It's just really fascinating to try and see, what do I need to know to solve this problem? Just the questions and the answers are always fascinating to me, and they're what make me love being an engineer.
I like to see the next generation of scientists and engineers get exposed to things that they hadn't thought of, to think of experiments in ways that we haven't thought of. Now you're becoming a scientist.
I think that everybody has questions, and to be a scientist or an engineer is to take those questions and to actively try to answer them.
The science worth doing doesn't get any easier. I think what motivates most scientists is what you get out of doing all that hard work, which is finding out these hard-won little kernels of truth about how the world works.
We never know where this pathway goes. Following your instincts, doing good science, following the technology leads that may come from that really can be tremendously important for our country, but also tremendously rewarding and satisfying for each of you.
To pursue science and technology internships, scholarships, and job opportunities at the Department of Energy, information can be found at the following sites.